All right. Hey everyone. Nice to see you. My name is Sampumon Kaipiainen. I'm from the University of Helsinki.
And I'm Matti Paksula. I come from a company called AppGyver. We do HTML5 wrapper that extends PhoneGap. And how that relates with Leaflet is that by this app we made with that. It's a sailing navigation app. It has Leaflet and 700 megabytes of map data stored in SQLite database. It's done with AngularJS, Leaflet, and D3.js. And yeah, that's about it. Sampumon.
All right. I work at the University of Helsinki, and currently I'm the main developer of this web user interface for the Superhub project. And it's a huge European Union project, and nothing else to say about that, except this is how it looks like, or the part what I'm doing. So it's a transport, it's a route searcher. Travel planner, yeah, excellent. And I'm actually gonna just show it quickly to you so you know what's it about. And here I have logged in and gonna do a journey plan. And the party internet here is a bit slow, so the map loads slowly. Anyway, this currently works only in Helsinki, Milan, and Barcelona, so it does not work in the States. Yeah, so this is the place where I used to live 2 years ago. And then my friend Mikko. Internet is slow. Oh, sorry, actually I made a typo. And my friend Mikko lives here, and this is me. And I chose this as an example because there's a lot of sea there, and in the winter you can actually ski on the sea. So we are gonna see some skiing routes soon. So let's do a search. Yeah, I just remember that the data which is coming through is huge and the internet is slow. Oh, excellent. So here we have the point in the journey planner of Superhub is that you can see all the different transport modes on the same visualization. So I have my bike and 6 kilometers of walking, and then I have public transportation. And I'm probably gonna choose the biking route. So let's continue. If we compare this to other journey planners currently available, we have Google, which just renewed its transportation thing, but still you only have this bus and driving routes on the same map, and you have to click to get bicycle routes. And it's even worse in Helsinki city public transportation because there's 2 different web services for public transport here, and then walking and biking. So the Superhub project is going to make that better. And now the best part is skiing. And this is the same place I used to live in 2 years ago. And these are all actual skiing routes or skiing tracks I recorded them with the GPS tracker. And I don't know if anyone else here has ever skied. Cross-country skiing, excellent. Yeah, good. So yeah, you need snow and you need winter, and we got plenty of that in Finland. So this actually, you can see that this B point here is where my friend Mikko lives. So I did ski a few times to his place. And this is a prototype. made with Google Maps, showing now 3 different journey plans. We have the green bike, then we have the blue bus route to my friend Mikko, and then we have the best option, which is skiing through the sea. And one feature coming into Superhub is this disruptive events. And here in the prototype, they are visualized in the same map as the journey plans. So I can check that, okay, this is where I would ski, but it says thin ice, so I maybe have to be careful. And here it's no ice, so I have to be super careful. And there's crappy plowing on the bike road, so I'm not gonna do the bike. I'm gonna ski. It's the best thing. And soon, when we went into development of Superhub and we are using Leaflet, we noticed that it gets kind of verbose, this JavaScript, and it's not really fun. It's messy. We'd like to do it better.
So, and this also applies to what we do with mobile app development. You know, a HTML5 is missing a geomap element because you have to do crappy JavaScript and Leaflet, and it gets super messy. But a fully DOM-driven approach would be really good. Just see how beautiful that is. You have element geomap, then you can add markers to it. You have elements there. So it's semantic, it's not JavaScript. And it's not tied to Leaflet either. And then for this disruptive event of no ice, you would have then a title and description. So the DOM is just great for that because of accessibility, and it's SEO friendly. That Leaflet or JavaScript is not. And it's super easy to debug with just Web Inspector. Try debugging some of the Leaflet messiness. It's hard. And it can be server generated. So you could just generate the whole map with markers on server side and then push that to the web browser. And that is just awesome.
Yeah, DOM is super great.
So we made this implementation. We would love to show.
Yeah, we're gonna show it to you. And I have it open here. So this is San Francisco. If we zoom in a bit, we can see there's one disruptive event report already. It says we have graphical web conference on Moscow Center, all right. Maybe we add another one. Here, say, it would be Doc is on loose. At least I don't see him here, so.
Somewhere, beware of him.
All right, now we have a new disruptive event on the geomap. And if we check the web inspector, we have the geomap element, and we have a new marker which says dog is on loose. And let's add another one.
Pull down that a bit.
Yep. Let's say that Bart is, the Bart strike is over, so okay. Bart runs again. We are misusing the disruptive events reporting system, but doesn't matter, it's a demo. And
so now magically you have another element there.
Yeah. And what's also cool is I can actually delete one of the markers from the inspector. So let's remove this dog is on loose because I believe that is resolved. And boom, it's gone. And this is DOM-driven geomap element, and it's great.
And once you add nodes here, meaning elements on the map. Then you can do stuff like organize them. So if you drag those around, you get nice Z-index kind of thing there, and just can extend that with different types of markers or point of interests or paths or routes. And yeah, so let's see the implementation, right?
Yeah, let's see it. Oh, by the way, someone is actually trying this. Don't worry. If you try something exotic, it's not going to work. We have not implemented most of the stuff. And this is the data flow in our prototype system. We have the backend, which gives us these disruptive events like no eyes or dog is on loose. And actually, we have D3.js in the middle processing the disruptive events. And D3 inserts marker elements inside the geomap DOM. And we listen that insert and mutation event and handle it in the geomap JavaScript engine and send currently a leaflet marker to the leaflet engine. We could plug in other engines, but of course we are first just doing one engine. Google Maps would be obvious second choice. And then Leaflet inserts the marker on the map. And when we clicked on the map, we get a leaflet event, which we listen and route back to actually our front-end code, because that's the code which knows what to do. And what to do is to create a new disruptive event. And we send it to D3.js to process. And then the cycle continues. And we get duckies on loose.
Can I add something?
Yep.
So the point here is that when you click on the leaflet map, what you would do in the old world or old style would be that you just do the leaflet thing. But now you don't. You use the same architecture that is loosely coupled. So you actually use the DOM as an API. This means that you can use whatever libraries you want to use that can modify DOM. And then it just works. If you make tight coupling with leaflet, then you're stuck with leaflet and you're not able to switch the engine behind the geomap element.
Yep. And we are just using D3.js because the nature of the disruptive events is they've come as a stream, and D3 is great for processing that. All right. And this is to recap. We are getting these disruptive events. It's XML, or we could call it DOM. Also, we are getting this from the backend. And then D3 inserts the marker element inside geomap. It's all really beautiful. Versus leaflet, which is crappy. Not to say the map engine leaflet is crappy, it's great, but messing around with this JavaScript code, that is crappy and messy. So we like to have DOM-based geomap elements, and a bit of note about the implementation. These are just the techniques we used. It's custom elements. We just insert the marker elements into the DOM of the geomap elements, which we also just insert to the DOM, and it automatically works. And the mutation observer is for listening to the insertion events. So again, it does not make any difference if it's D3.js or yourself via the web console inserting elements. It works because we are listening to the mutation events. And shadow DOM is hiding the gory leaflet SVG DOM so that we are not actually seeing it. And it's here inside the geomap element, this document fragment. You have to turn on a shadow DOM in the web inspector if you want to see it. But this is where the huge leaflet DOM is, and we don't have to look at it and deal with it at all. And we tried to use Angular for doing the mutation observing, but didn't get it to work.
Because Angular doesn't support mutation events at all, and it works with data binding, and that's sad. Because Angular would be a so good fit for this.
Yeah, I mean, we thought that Angular would be exactly what we want, but it could be useful addition, of course, but it didn't do the main thing we needed to do, which was the mutation observing. But anyway, there actually is already libraries for doing that. And the libraries are this Polymer and Mozilla Xtag, and they do web components. And that's a future, that's what our geomap is. It's a web component. You can just add it to any page and add the markers, and it works, and it's beautiful. And it includes love. And there's actually the smallest text there is to the HTML5 rocks tutorial about custom elements, and it's a great read. I recommend it to everyone. And how could we add more love to the web components?
I don't know.
All right. Yeah, now I remember what I want to say. So we are actually doing web components via the raw API. We are using Shadow DOM and custom elements. But these polyfill libraries, and I believe the Polymer is at least it's a bigger one of these. What that does is that you can actually use web components right away. It works in any modern browser if you use the polyfill library. Would you have some questions?
So I noticed that you didn't have a dash in the geomap tag. Don't they usually require that there's like a dash in the tag name?
Oh yeah, they do. Actually, I did a bit.
Repeat.
So why don't we have a dash in the geomap element name? So it would be like x-geomap. And that's true. I experimented with Mozilla X tags and Polymer, and they require the dash. And then I'm not sure if you would use the correct API for creating custom elements, if you would need to have the dash. But we just kind of hacked it in and appended the element to the DOM, and it worked. So that's why no dash.
Yep.
What made you choose Leaflet over a different Maps API?
Actually, well, I did love Leaflet already before, but the Superhub European Union project has this rule that you have to use open source. So we couldn't use Google Maps. That's the main reason. But Leaflet is really nice for maps anyway.
And Leaflet works very well with, for example, SQLite. So you can pull your map titles from Leaflet. And yeah, we love open source. Yep.
When you said that it had 700 megs of data inside SQLite, what's that data that you're talking about?
The map titles in this app.
Okay.
So it's an HTML5 wrapped app with Leaflet, and then there's a SQLite database bundled in that app, and that SQLite database contains the map tiles. Yep.
Are you guys using any kind of transport layer optimizations?
Transport layer optimizations.
Yeah. So yeah, I saw that you could transfer some large pieces of XML data.
Yeah, okay. Actually, the large pieces of XML or large pieces of data, which I was probably talking about, is these Johnny plans, which come from Superhub, because it's sending all the nodes in the plan. That is all the points in the path, and it's doing it in a super verbose way. So that's the huge amount of data, but here, if we, in the prototype, we have these disruptive events, and that has not yet been implemented in the Superhub, but then it wouldn't be huge data at all because it's just one small chunk of XML per disruptive event. Of course, if you would have a huge amount of disruption, say the world would be collapsing, then it would probably collapse anyway. But no, we don't, and I'm not sure if we answered your question.
You answered well enough.
Okay, great. Yeah.
So you shown you putting inside your DOM just map markers. Did you go farther to have the more complex geometries? Polygons, multi-lines?
Yeah, not yet. So currently we only have the macro element, and the obvious addition would be these paths for routes.
Yeah.
Would of course be also on the geomap element.
We could show you the code after answering all the questions. So, because it's really easy to extend. Yep.
Are you planning on continuing to improve on the geomap thing and then adding new stuff and maybe porting into Polymer or something?
Yeah, if you and other people keep asking, then we will.
We really believe that in HTML5 there should be a geomap. Preferably map, but that's already taken.
Yeah, for the image map, which is obsoleted. But it's like you can do it with a web component, and that would be excellent, and that's something we could do and continue our work. But also map is kind of it's so big element nowadays that it should also be native, but probably that will not happen in 10 years. And there.
Did you have any front-end performance issues, and what did you do? What were they? How did you solve them?
Yeah, sorry, which issues?
Performance issues.
Performance, like too many objects in the SVG or something like that?
Do you mean with Leaflet?
Yeah.
No, actually no. I mean, even though in the actual Superhub web user interface where we have a lot of routes, and I mean this data which comes, it can be like I don't know, 1 megabyte of path data, but it seems that Leaflet is really efficient, and we have not come to any performance issues. It could be that once we also add the disruptive events and maybe some other data, I don't know, but not yet, no, not at all. Yep.
The question, what do you lose using Leaflet rather than maps, Google Maps?
Oh yeah, that's we answered already because Leaflet is open source and the Superhub European Union project requires that. Oh yeah, okay.
What do you lose? What does Google do instead of Leaflet?
Okay. Well, actually, my opinion is that I would use Leaflet anyway because it has more love in it. But one thing we did lose is that we are using nominative for the autocomplete of the addresses, and it's not as good as Google's autocomplete, but we cannot use it. Sorry?
What's it called again?
Nominative. Oh.
It's not available, but
The internet is not available, but it's from OpenStreetMap project. It's the geocoding engine, and you can do autocomplete, kind of. Actually, not really. That's why it is a bit crappy, and Google does it better. But it's for geocoding. Yep.
So it does geocoding, does it also do routing? Or
Yeah, it does, but actually the Superhub project is not using nominative for calculating the routes. Instead, there's people in the Czechs who wrote it with Java by hand from scratch. And it took some time, but I don't know, maybe there's probably some few...
But there are some projects. that do that as open source?
Yeah, there is this OpenTrip planner, which is what a lot of people think that we should have used. But anyway,
Including me.
yeah. But anyway, it's now coded in Scratch with Java, and it works, and no problem. And the last question.
Can you show me the code?
You want to see the code?
Yeah.
All right, which part do you want to see?
The part where you could extend it to support paths.
All right. So here is...
Can you increase the font also a bit?
I can, yeah,
Thank
it's
you.
easy. So here is the code of the geomap element, and this chunk here is the marker which we are using. And you can see that we are checking that if our map engine is Leaflet, then we are creating an Leaflet marker, and that's all. So for markers, it's super easy to add other engines, and it's also somewhat easy to add other elements than marker, but I haven't even been thinking about it yet.
But you can totally do it.
Yeah, you can totally do it. It's just a bit more code, but I don't know. It's this is, and it doesn't matter if then we just wrap the ugly JavaScript inside here, and then we use the DOM, and everybody is happy. What else do we want to see?
Can you use how you use Shadow DOM?
Yeah. As soon as I find it, it's not in the Shadow DOM HTML file if you are thinking about that. All right, I found it. So this is actually we are creating the actual geomap JavaScript object for the geomap element, which is already in the DOM. And then this is where we create the Shadow DOM, and it's quite easy. And this currently probably only works in Google Chrome, but if we would use Polymer for polyfilling this stuff, it would work in all major browsers.
That satisfies my question.
Excellent. Yep.
Sorry, I know you already covered this, but I did a late quick recap of what part D3 plays.
Good question.
Show me the D3 implementation.
It plays a super minimal part currently in the prototype because we are not getting the stream of disruptive events from the server. We only handle the map clicks, and this is it. And this is where D3 appends a marker element.
Can you go through line by line, starting from line 40?
I can. I don't really want to, but I certainly can. All right. So we are selecting the geomap element, which is already present in the HTML5. You put it there, and then the geomap code grabs it. And then we choose or select all the markers if there's some markers already in the DOM, and
What's the data part?
The data part is the current set of disruptive event markers. But since we are going through the code, actually what happens now is that here's the click handler, which comes from Leaflet into our code, and we just send this one new marker to the D3 handler. And what we don't do at the end of the D3.js handler is we are not removing any old markers. So that's why all the markers stay in, and that's why it's fine to just send one new marker. But the nature of D3 would be that we have an array of markers, which and new markers come from the server, and then we update the whole set with D3, and D3 then knows which are old and which are new, and we could add a fading animation for old ones and a blink to new ones and that kind of stuff. But currently on the prototype, we just add one marker at a time from the click event on the map. Yeah, we are just sending one marker, and we are actually not storing the whole data set as in a D3 form anywhere. I think I was going through the code somewhere around here, but like I said, I don't really want to go through it. But this is really basic D3.js, and D3 is really great for handling this data in the future when we actually have the data.
Okay.
All right.